Arithmetic sequences and series. A sequence is a set of numbers written in a specific order. You will notice that the list of numbers will be separated by commas. It will have subscripts of 1, 2, 3, 4, and so forth, denoting the position that that number is sitting in on that list. A1 will be referred to as the first term, A2 will be second term, and so forth. The 1 and the 2 again tell you which term position it is sitting in. The n values will always be the natural numbers, the counting numbers, and we are able to define a sequence as a function. So for every input value, there will be an output value. Now, this list, this sequence of numbers, must always have some sort of pattern, okay? So here's an example of a simple sequence of numbers that is arithmetic or arithmetic. You can pronounce it one of two ways: 2, 4, 6, 8, 10. And you can easily guess what the numbers will continue to be, as you notice that these are numbers that are even, okay? They are increasing by a pattern of adding by 2. If we were to write a formula that describes what is happening here in these numbers, we could easily say that a sub n is 2 times n, because in the first position, if n is 1, 2 times 1 would give us a 2. In the second position, 2 times 2 would give us a 4, and so forth. So what I'm going to have you guys do, first of all, is find terms of a given sequence when the formula of that sequence is provided, okay? Now I want you to notice that these work just like regular function notation, where the f of x value, so to speak, is your a sub n term, and then the n values are your x's, the input values, okay? So what I want you to do is I want you to follow along with me and do part A. We're going to find the first 5 terms and then the 100th term, and then I'll allow you to have some time to do B, C, and D on your own. So let's go ahead and do so. So I divided up these into 4 sections so that we can separate our work for each one. So part A is a sub n equals 2 times n minus 1. So if I want to find my first term, a sub 1, I replaced n with 1 for the first term. Therefore, for every n, I must replace it with a 1. When I simplify, 2 times 1 is 2, 2 minus 1, my first term is a 1. I will repeat for the second term. Substitute n with 2. 4 minus 1 is a 3. I will continue this pattern, and then I start noticing that I see a trend. 1, 3, 5. So if I had to guess, 2 times 4 is 8, 8 minus 1 is going to be a 7. I'm increasing by 2's, right? And it stands to reason, because if you notice here, that's a linear equation, is it not? mx plus b, the slope is a 2, it's positive 2, so it's increasing by 2. That's the y-intercept, right? The y-intercept is the starting value, so the starting value is when x is 0. So if I backtracked and did 1 minus 2, right, wouldn't I be at negative 1? So hopefully you see how arithmetic sequences are mimicking the behavior of a linear equation. If I had to find the 100th term, I'm not going to just continue finding every single term until I get the 100th term. That would be quite inefficient. So I will just go straight to the term that is being requested, and I substitute that value into the equation, and 200 minus 1 is 199. So take a moment, pause the video, and I would like you to work B, C, and D, find those values for the first 5 terms, and then skip over to the 100th term and give me that. Pause the video now. All right, welcome back. Check your answers against the answer key being provided. So sequences can have different types of patterns occurring. So notice that in part A, they were consistently increasing by 2. Over here, the pattern wasn't an adding type pattern. We started noticing that for every value that increased in the denominator, the numerator was 1 less. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and so forth. And you can see different types of patterns that continue happening, okay? And all these, it was 1 less than the perfect square, you know. So, what exactly is an arithmetic sequence? Okay, so an arithmetic sequence is going to happen when the differences between 2 consecutive terms are the same. So when I'm giving you a sequence of numbers in a particular list, what you would do is you would take the latter term minus the previous term. So whatever number goes right here, you would just subtract it, and you take this number and subtract it from the number in this position, and take this number and whatever number is in that position, subtract it. And if every single time you do that consistently, the answer is some number D, then we will call that an arithmetic sequence, because consistently the difference between the latter term and the prior term was the same number. So always remember that this notation here just means take the latter term and subtract the prior term, and that will give you a value. That value D, if it is consistent, will be known as the common difference. So let's see what that means in the next example. So they gave us an equation, a sub n equals 3 minus 4 times n plus 6. I want you to do just like we did in example number 1 and go ahead and find the first 5 terms. Pause the video and come back to me. Okay, so substituting the values of 1, 2, 3, 4, and 5 into that formula yielded the answers -5, -29, -33. I started noticing that the numbers were developing a pattern of decreasing by 4. So I no longer proceeded in substituting. I just continued subtracting by 4. -33 minus 4 is -37. -37 minus 4 gave me a -41. Because of that pattern of consistently decreasing by 4, I was able to determine that yes, the sequence is arithmetic because my common difference was a 4 but decreasing. So I need to make sure I stipulate that by putting a negative in front of my 4. Okay. Sometimes you will be given a sequence of terms and asked to find the explicit formula for that sequence of terms. So you will see that the list of terms have a particular pattern, and developing a formula for that pattern helps you find any term in that sequence. The explicit formula for an arithmetic sequence is a sub 1 plus n minus 1 times d. We have already talked about a sub 1 being the first term given in that sequence. D is the common difference and the N stands for the number of terms. So if you need to put yourself a reminder, number of terms. D is the, well, actually, you know what? I'm just going to use the already typed out common difference. And A1 is your first term, okay? So let's look at example 3. They want us to find the 25th term of this sequence of numbers, okay? So the 25th term is A sub 25. I see a list of numbers, 5, 11, 17, 23, 29. I've been given A1, A2, A3, A4, and so forth. Do I just continue going, writing out those numbers until I get to the 25th term? Sure, that is one way to do it, but inefficient. And I want you guys to be able to show me that you are able to find any term, not by doing it the inefficient way. I want you specifically to develop an explicit formula to be able to find that specific term. So how exactly do we do that? So let's write out the explicit formula. A sub n equals A1 plus n minus 1 times D. What I want you to make a habit of is when I ask you to find the explicit formula, I need you to find A1 and D. Either it's being given to you or you need to determine it yourself. So A1 is first term. Are we given an A1? We are. A1 is the first term of the sequence. How about the common difference? The common difference is the latter term minus the prior term. We do have D, because D can be found by taking any latter term, like say 17, minus the prior term, and I get a 6. I'm going to go ahead and make sure I check it. Does 23 minus 17 also give me a 6? Yes. So D is established as my common difference. So my explicit formula will be when I finish substituting those values into my problem and simplifying. A1 was 5 plus n minus 1, and my D is my 6. I'm going to get rid of my parentheses by distributing, because order of operations says to do parentheses first. That implies distribution. So the 5 comes down, plus 6 times n is 6n. 6 times negative 1 is 6. And if I combine my like terms, I get 6n minus 1, or negative 1 plus 6n. Okay? So A sub n equals 6n minus 1 is my explicit formula. So now A sub 25 is that much easier to find, because all I have to do is 6 times 25 minus 1, and you do that calculation, and what do you get? A sub 25 is 149. This is your explicit formula. So the value in finding an explicit formula is you can find any term once you have that formula. Okay? All right, moving on. Example 4 is an example of how sometimes they are not going to give us the first term and the common difference to easily find a term. So here's an example where we're given a random term, but we are asked to find the very first term of the sequence, okay? Here goes. Find the first term, a sub 1, of the arithmetic sequence if the ninth term is 72 and the common difference is 5. So the ninth term is 72, is written as a sub 9 equals 72. The common difference is 5, is the same thing as saying d equals 5. And we need to find the first term, a1. So I'm going to write this down here. I need to find a sub 1. Okay? So using the explicit formula, a sub n equals a sub 1 plus n minus 1 times d, or by the way, I meant to tell you guys, if you want to write it this way, d times n minus 1, that also is absolutely acceptable. All right? So a sub n equals a sub 1 plus n minus 1 times d, or d times n minus 1. Multiplication is commutative, so you can rewrite it like that. For some reason, most books like it written in this fashion, but anyhow, here goes. In this problem, they gave us the ninth term to be 72. The ninth term to be 72. So A9 is going to be 72. A1 is our unknown. I'm going to circle it because A1 is what we're looking for. So that's our variable, our unknown variable, plus D was given us to be 5. N stands for number of terms. Well, if this is the ninth term, we can pretend that that's the last term of our sequence. That implies that we have 9 terms total. Let's do the math. Simplify. 5 times 8 is a 40. And to isolate A1, we would need to subtract 40 on both sides. I'll write it real small here. So that positive and negative 40 zeroes out, and A1 is the result of 72 minus 40, which in this case is a 32. And that is the answer we were looking for. And the good thing about finding the first term is that once you have that first term, you can establish what the explicit formula is. Again, here they're not asking us to find it, but let's go ahead and practice writing it out. A sub n equals, remember with explicit formula, I only need you to substitute A1 and D. My A1 we just found, plus the D was given to us as 5 times n minus 1. So we distribute and we get 32 plus 5n minus 5. So my an formula, or my explicit formula, would be 32 minus 5 is 28 plus 5n, or 5n plus 28. So I'm just going to put like a little cloud around this because it wasn't really asked, but I wanted to make sure you understand how to find explicit formula. All right, arithmetic means, moving on. Arithmetic means are the terms between any two non-consecutive terms. Non-consecutive means they do not go one after the other. So an example, 17 and negative 18, those are non-consecutive terms because they don't go one after the other. Negative 11 and negative 18, they are right next to each other. Those are consecutive, okay? So terms that are non-consecutive are considered means, arithmetic means. So here's my question for you. Between 10 and negative 18, what are the 3 arithmetic means? Well, visually we can just see that they are 3 -4, and -11. Okay, so that's what the word means. So find the three arithmetic means between 8 and 14. So visually, what does that look like? Well, 8 is a term. We can consider that to be the first term, but then they're not specifically telling us that. But they are telling us that between 8 and its other mean, 14, its other term, 14, there are 3 missing terms we refer to as means, okay? And they have tasked us in finding out what that is, all right? So, what do we need to be able to figure out what those are? Well, we know it's arithmetic, so we know that the numbers, if they have to go from 8 to 14, that the D value, whatever they're adding by, is positive, okay? We don't know what that D value is, so we need to look for it. So using our arithmetic formula, let's go ahead and write that down, that we need the common difference so that we can figure out what those missing terms are. So if I'm looking for D, just like I was looking up here in A sub 1, I need to substitute everything else so that I can isolate D. So A sub n stands for number of terms. We have 1, 2, 3, 4, 5 total number of terms. So what is A sub 5? A sub 5 is the 5th term. So I need to go to the 5th term, 1, 2, 3, 4, 5. It is 14, so A sub 5, I'm going to put 14. A sub 1 is the first term. My first term is an 8. Plus number of terms, we have 1, 2, 3, 4, 5 number of terms. And D is what I'm looking for. Again, N is number of terms. We have 5 number of terms, so A sub 5 means 5th term, okay? That's the 5th term. A sub 5 is the 5th term. So we substitute the 5th term to be 14, okay? First term is 8, 1, 2, 3, 4, 5. So let's simplify. That goes first. So 14 equals 8 plus 4 times D. I need to solve for D. Basic algebra. I need to subtract 8 on both sides. So 6 is equal to 4 times D. I need to isolate D by dividing by 4 on both sides. 6 divided by 4 is 3 over 2, which is my D. 3/2. So I'm going to consistently add by 3/2. I know A1 is 8, so to find A2 in the second position, that means A2 is the second term. I need to take the 8 and add 3/2 to it. And when I do 8 plus 3/2, I'm going to end up with 19/2. And I will do that 3 more times, or 2 more times, to find A3 and A4. Take the previous answer and add 3/2. 19 plus 3 is 22. 22 divided by 2 is 11. A sub 4 turns out to be 25/2. And then if I add 3/2 again, I should end up with 14. Well, 25 plus 3 is 28 over the common denominator 2. 28 over 2 is 14. Okay? There's something that I showed students on the calculator that I want to show you. So let's type in the 8 of the first term and add the 3/2 by doing alpha y equals. I write it as a stacked fraction and I hit enter. There's your 19/2, right? If you repeat the process one more time on the calculator, so I'm going to hit enter to oh goodness. Let me start over again. 8 plus 3 over 2. And then you repeat the process by saying, take the previous answer and add 3/2. So all I did was hit the plus sign, okay? So that the ANS comes out. The calculator notices the pattern of you having added 3/2 twice. So it will continue to add 3/2 as you press enter. Okay? It would just keep adding 3 over 2. So once you do it twice, it will continue doing that pattern. Okay, last concept for today. The sum of the finite arithmetic sequence is known as the nth partial sum, and it is given by this series formula, S sub n equals n times the quotient of a sub 1 plus a sub n over 2. N still stands for the number of terms. A1 is the first term, A sub n is the last term of that finite arithmetic sequence. Finite being that it is a terminating sequence, okay? So this is an example of a series formula. Series merely means is that you are going to sum up the terms of your sequence. So whatever all those numbers in your list is, you are going to add them up. In this particular problem, we are going to use example number 3, okay, where they only gave us the first 5 terms. But they want us to list all 40 terms. Well, they don't want us to list it, sorry. If they were all listed, they want us to add up all those 40 terms, okay? So we're not going to sit here and fill out the next 35 terms and then sit there and add them all. There's a more efficient way of doing so, and we're going to use this formula, all right? So they want us to add 40 terms, so S sub 40 is what we want to calculate. S 40, meaning the sum of the first 40 terms. The n value we know is 40, and we know we need to multiply. The sum in the numerator has to be a sub 1, the first term. Well, we know that a sub 1 was a 5. So I'm going to put that 5 plus a of whatever the n is. Well, our a is 40, so a sub 40 means the 40th term. Well, we only have a sub 1, 2, 3, a sub 4, a sub 5. We don't know what a sub 40 is way over here, right? So I'm just going to put a placeholder here as a sub 40 because I don't know what it is, 2. So I need to go find it, all right? I need to go find a sub 40 so I can just finish off that formula. I'm going to use my nth term formula, right? My nth term formula in example number 3 was, where is it? I'll get there. 6n minus 1, right? So let's come back down here and use that formula to find a sub 40. What was that? 6n minus 1. So a sub 40 is going to be 6 times 40 minus 1, right? 240 minus 1 gives me 239. So now I can go right back to where we were, put the 40 times 5 plus the value we now know over 2. And when you finish typing all that out, you should get 4,880 as the sum of all those 40 terms. Even though we don't have them all listed, we are still able to calculate that sum. And that's it. That's arithmetic series for you. Thank you for watching.